Okay, the store instructions, floating point store instructions. Pretty similar, except I've got a couple of new things. You'll notice that I've got a P suffix for float store and float integer store. I'll tell you about those. Let's start at the top. The first one, float store, is going to copy the stack top to memory. So stack top gets copied to memory. This does not change the contents of a floating point stack register. This instruction, however, does. This is going to do two things. Stack top gets copied to memory, and then stack top is popped. Okay, so it kind of cleans up the stack as it's going. In a similar manner, whatever is on the stack top, it's going to be demoted to an integer value and copied to memory. If I also want to pop stack top while I do that, I will use fi store. So this is integer store with popping. Stack top's going to go to memory, and then stack top is popped off the top. Okay. Now, as we go on, you're going to see some patterns in the types of instructions and what we're able to do. This will help quite a bit. Let me show you the exchange instructions, because we're going to do those examples in class. Exchange values work very similarly to the exchange values we were first introduced to back in chapter 4. What they do is, I've got two versions. F exchange, this has no operands at all, because what it's going to do is exchange stack top and stack top 1 automatically. Okay, so as you might suspect, the second one is going to exchange stack top and whichever of the stack registers are indicated in the instruction. Okay. Alright, let's see. I think I have addition. We'll do that in class. Let's talk about fadd. Fadd, cool thing. I know I keep saying that. These are, you know what, seriously, these are probably some of my favorite instructions in assembly language, just because they combine so many things. This does two things. It's going to pop stack top and stack top 1. It's going to add them together and then push the sum back on the top of the stack. Okay, so it pops these two, adds them together, pushes them back to the stack top. Okay, fadd, when I have operands, I can do something other than just stack top and stack top 1. This, we're going to replace stack top, so stack top equals stack top plus whatever other stack register we indicate. I can also do the same thing, except again, I get a hint here. The order of operands has changed, which means where the result is going to get stored is the destination, or what we would think of as the destination. Okay. Finally, fadd and pop. This is going to do the same thing that we did up here. We're going to add stack number plus stack top. Stack number gets replaced with that sum, and then old stack top will be popped from the stack. Okay, that P suffix, very handy. Okay, what else have we got? A few more adds. these are looking pretty similar. This is going to add stack top at the real value stored in memory. The sum is going to be placed on stack top. So stack top equals stack top plus that real or floating point value in memory. In the same way, stack top is going to get replaced by the sum of stack top plus the integer value stored in memory. Okay? Again, we've got some more examples to look at, plus some code that we'll do, I think, at this point when we get back into class. What else have we got? As you might suspect, okay, subtraction. This is going to follow pretty closely to what we were talking about with addition. So here I'm going to pop ST and ST1. The difference is going to be pushed back onto the stack. So I'll just write it that way. Difference goes to stack top. Okay? Alright, this does the same thing, but it doesn't pop anything off. This is going to calculate ST number minus stack top, and I'm going to replace, the difference will go to ST number, since that's my destination. Okay? This does the same thing, however, what it's going to do is stack top minus ST number, and the difference will go to stack top. Okay? Alright. Got a few more subtractions, then I've got a surprise for you. Okay? So we see here that we've got the same pattern that we saw in addition. I am going to, in the first case, I am going to calculate stack top minus the value in memory, the floating point value in memory. The difference is going to be stored on stack top. I've got integer now, so this is going to calculate stack top minus the integer value stored in memory. That difference will be pushed on the stack, or will replace. I erase that. It does not push anything, it replaces stack top. Okay? But now I see I have my P suffix, so this one's going to calculate ST number minus ST in this case. I'm going to replace stack top number, and then I'm going to pop the top of the stack after doing that. Okay? Alright, now for the surprise. We noticed in addition that I didn't have to reverse my operands. Why? Because in addition I could say 3 plus 5, but that turns out to be the same thing as 5 plus 3. So it really, order of operands didn't matter. That's not the case for subtraction. In subtraction, it does matter what the order of my operands is. So if I need to reverse the order of the operands, instead of doing, for example, in F sub, we calculated stack top minus stack top 1, we popped them both, calculated the difference. In this case, we're going to pop stack top and stack top 1. So pop. We're going to calculate, in this case, stack top minus ST1, which is opposite. In F sub, we did ST1 minus ST. Okay? And then the difference will get pushed onto the stack. Okay? Alright, so reverse instructions. Just keep these in mind. These are going to come in handy. We'll see these for subtraction. We'll also see them for division for the same reason. Again, subtraction, unlike addition, is not commutative. So I've got to have these reversed instructions. In the second case, we are going to calculate ST minus ST number, and ST number is going to get that difference. Okay, in the last case, I'm going to calculate ST number minus ST, and this will replace stack top. Okay, a couple more. I've got real and integer memory possibilities. So this is going to, in this case, we are reversing. So this is going to be memory minus stack top, and difference replaces stack top. Okay. In this case, integer subtract, reversing is going to be that integer value in memory promoted to an extended double minus stack top, and the difference here replaces stack top again. Okay, alright, finally, now I have both reverse and pop. So I'm going to do the operation, and the very last thing I'll do is pop the top of the stack. So first thing we do is we're going to calculate ST minus ST number. Then we're going to replace difference, or replace ST number with the difference, and then pop the top of the stack. Okay? Alright. So I tell you what, we'll call it a video there. We'll pick up with multiplication on the next one.